Welcome back to our Biostatistics Week 5. Today we'll explore the fundamental rules of probability and how they apply in biological and health-related research. These rules allow us to calculate probabilities of multiple events, which is essential when analyzing clinical trials, diagnostic tests, and more. Why do we need rules for probability? Because many real-world problems involve more than one event. Think of calculating the chance that a person has both a genetic trait and a disease, or the chance of recovering from two simultaneous conditions. The rules we learn today, addition, multiplication, and complements, help us handle these kinds of compound probabilities. The addition rule is used when we want to calculate the probability of either event A or event B occurring. If the events are mutually exclusive, meaning they can't happen at the same time, we simply add their individual probabilities. For example, what is the chance of randomly selecting a blood donor who is either type A or type B? If 40% are type A and 11% are type B, then the total probability is 0.40 plus 0.11 is equal to 0.51 or 51%. When events are not mutually exclusive, we need to adjust for the overlap by subtracting the probability of both occurring. This is the general addition rule. P, A or B, equals P, A, plus P, B, P, A, and B. For example, suppose 30% of patients have high blood pressure, 25% have high cholesterol, and 10% have both. The probability of having either is 0.30 plus 0.25 to 0.10 equals 0.45 or 45%. Now we turn to the multiplication rule. When we want to know the probability of both A and B happening, and the events are independent, we multiply their probabilities. For example, suppose there's a 0.6 chance that a patient follows a diet and a 0.8 chance they exercise regularly. If the two behaviors are independent, the probability that they do both is 0.6 times 0.8 equals 0.48 or 48%. When events are not mutually exclusive, we need to adjust for the overlap by subtracting the probability of both occurring. This is the general addition rule. P, A or B, equals P, A, plus P, B, P, A, and B. For example, suppose 30% of patients have high blood pressure, 25% have high cholesterol, and 10% have both. The probability of having either is 0.30 plus 0.25 to 0.10 equals 0.45 or 45%. The complement rule helps when it's easier to calculate the probability of something not happening. The formula is P, A equals 1, P not A. Let's say the chance of side effect from a medication is 0.15. Then the probability of not having side effects is 1 to 0.15 equals 0.85 or 85%. Let's use Excel to apply these rules. Use the attached dataset showing the probabilities of various health conditions. Use the attached step-by-step document to follow this video example. Pause the video and follow along. When you're ready, we'll try it in R. And our probability rules are easy to script. Follow the video example. The script for this is attached beneath the video. Pause or rewind the video and make sure you understand each step. Use the addition rule for or situations. Use the multiplication rule for and situations. Always check whether events are independent or dependent. The complement rule can simplify calculations. Understanding these will improve your statistical reasoning in real-world biological and medical contexts. Now let's test your understanding. You'll be solving questions using the rules we've covered. These include determining when events are independent versus dependent, applying both addition and multiplication rules, and using Excel or R to verify your answers.